In the following lesson, we introduce the T distribution, which is very similar to the standard normal distribution and has business applications in constructing confidence intervals and hypothesis testing, which are topics to be covered in later lessons in this course. We demonstrate the Excel functions associated with the T distribution, namely the T.DIST function. Before we introduce the confidence intervals and hypothesis testing, some very important business statistics tools, we need to introduce yet another continuous distribution, the T distribution. We introduced in course 2 of the specialization the most popular continuous distribution, namely the normal distribution. The normal is a symmetric continuous distribution with two parameters, the mean and the standard deviation. We also introduce the standard normal distribution, which simply is a normal distribution with a mean fixed at 0 and standard deviation fixed at 1. That is, it is a symmetric distribution centered at 0 with a fixed standard deviation. Another continuous distribution similar to the standard normal is the T distribution, also known as the student's T distribution. This distribution, just like the standard normal, is also a symmetric distribution centered at 0. That is, it has a mean equal to 0. However, the spread or the standard deviation of this distribution depends on a single parameter called the degree of freedom, commonly denoted by df. As this degree of freedom increases, the T distribution becomes closer and closer to the standard normal distribution. Accordingly, the T distribution is uniquely identified by this single parameter, the degrees of freedom. Let us take a look. In this spreadsheet, we have two distributions. The dotted blue line is the standard normal distribution, that is a normal distribution with mean 0 and standard deviation 1. The graph with the red line is a T distribution, and in this case a T distribution with degrees of freedom 2. Let's see what happens if I change the degrees of freedom of this T distribution. So if I change it from 2 to 3 to 4 to 5, notice that the T distribution is getting closer and closer to the standard normal distribution. If I change it further, increase it further to 10, the degrees of freedom 10, maybe 15, maybe 20, it gets further close to the standard normal distribution. 25, if I increase it to 50, even more close to the standard normal. If I increase it to 100, so as you see, beyond certain point, the T distribution, as the degrees of freedom increase, is indistinguishable from the standard normal distribution. The T distribution, unlike the normal distribution, does not have any standalone business applications. Rather, it is used as an interim tool for the calculations used in coming up with confidence intervals and hypothesis testing, which we will be introducing in subsequent lessons. Just like any statistical distribution, the T distribution also has an associated probability density function, a continuous density function. However, we will not be introducing the same in this lesson. You may look it up in any textbook or internet references. What we will introduce is the associated Excel functions to calculate various probabilities and outcomes using the T distribution. These are the T.DIST and the T.INV functions. These functions are analogous to the norm.tist and the norm.inv functions we introduced in course 2 with reference to the normal distribution. The T.DIST function calculates the area under the curve or the probability in a T distribution to the left of a number. The syntax of the function is T.DIST and it takes in 3 inputs: T.DIST open parenthesis, the first input is the number to the left of which you wish to calculate the probability in terms of notation typically denoted by lower case x. Then you give the degrees of freedom and finally the word true. This would calculate the probability or area under the curve to the left of x. As with the normal distribution, in the t distribution, the possible values that the random variable which follows the t distribution can take ranges from negative infinity to positive infinity. So, if you wish to calculate the probability to the left of 1.3 in a t distribution with 21 degrees of freedom, you would use the syntax is equal to T.DIST 1.3 21 true. Let us illustrate this in Excel. In the spreadsheet, we would type is equal to T.DIST open parenthesis 1.3 comma the degrees of freedom 21 comma true close parenthesis. So, this would give us the probability to the left of 1.3 in a t distribution with degrees of freedom 21, and the answer is a probability of 0.8962 or a chance of 89.62%. Similarly, if you wish to calculate the probability to the right of 1.3 in the same distribution, you would do a 1 minus T.DIST 1.3 21 true, using the fact that the area under the entire curve is always equal to 1, the answer being 0.1038. Extending the same logic, probability in the t distribution which has 21 degrees of freedom between negative 1 and 1.3 is the area under the curve between negative 1 and 1.3, which is calculated as is equal to T.DIST 1.3 21 true minus T.DIST negative 1 21 true, the answer being 0.7318. Remember, as with the usage of norm.dist function, we will not be using the T.DIST function with the false option in the syntax. Some of you may wonder what are degrees of freedom. One way to understand it is to simply tell yourself that it is the parameter of the t distribution that uniquely identifies one t distribution from another. Just like in the case of a normal distribution, the combination of two parameters, the mean and standard deviation, uniquely identify one normal distribution from another. Another way to understand the degrees of freedom is to think of it as a mathematical constraint imposed by the data based on what we are trying to estimate from the data. This notion will become apparent when we put to use the t distribution as an interim calculation in subsequent lessons to come up with confidence intervals and hypothesis testing. Using this notion, the degrees of freedom get linked to the size of data being used. So, a t distribution using a larger set of data would have a greater degree of freedom than a t distribution using a smaller set of data. And as we have seen in this lesson, as the degrees of freedom increase, the t distribution becomes closer and closer to the standard normal distribution. So, this is the first Excel function associated with the t distribution, the T.DIST function. In the next lesson, we will introduce the second function, the T.INV function.